All right, a few more things. I'm just going to comment. You don't have to understand this proof at all here, but I think it's kind of cool. And if you wanted to learn more about it, you could search for this on YouTube or follow that link if you can follow it. Pretty much what this picture shows, the video goes through the whole proof, but it pretty much shows that the sine of a plus b, this whole length, is equal to this right here plus this right here. And that is actually what the formula shows. Also, what this diagram shows is that if you want to find this length here, which is the cosine of a plus b, you actually have to do some subtraction. You have to start with this whole length here, right? This part here, and you have to subtract or take away from it this part right here, which is actually this part right here. This is what you have to take away from it. And that actually matches our formula because we see that the cosine of a plus b on the left here is equal to the cosine of both minus the sine of both up here, right? So now I've made this really messy, but all I want to say is that you don't have to understand the proof, but do just believe that it actually works. And if you want to understand a little bit more and understand why this is what it is here and why this is what it is here, then go ahead and watch the video. All right, so let's move on, and I just want to finish up a couple of things in our notes. I'm going to undo some of this messiness here. I want to finish this off here. So we talked about this. U is theta, or sorry, pi in this case. So we'll plug in pi for U, and V is pi over 2. So I'm going to go ahead and finish this, but maybe don't look at the screen if you can solve it for yourself. So we can see that we actually get the same answer no matter which way we do it. But again, there's a lot of times where we're not going to have the luxury of doing it this way on the right-hand side. We're not going to be able to know what the sign of this is, and so we're going to have to do it this left-hand side way. So the two practical uses of the sum and difference identity are to find, for example, like we did down here, to find the cosine of an angle that we don't actually know by splitting it apart. Or the other way we really use it a lot is to prove identities. So you'll notice on the next page, when you go ahead and try to prove this identity, you'll notice that this is a cofunction identity, both of these. They're on your identity sheet. We know these to be true because your sheet told you it was, and we actually thought through it quite a bit. We thought through how the sine of this angle and the cosine of this angle are actually exactly the same previously. So we know them to be true, but example 3 is asking you to really verify them and prove that they're true. So by breaking them apart the way you know how to do, the way we just learned, you'll actually be able to see that you do get sine x on the left side here. This will end up reducing to sine x just like the right-hand side says it will. Just keep in mind as you're practicing these that you need to get, that you need to remember your formulas. So there's a good chance to practice cosine. I was going to have two cosines together. That stays the same, but the sign of negative changes, right? Whereas for sine, the sign will stay the same. We're going to have a big old minus sign here. But what's different is one is sine and one is cosine, right? And then one is cosine and one is sine. So then you go ahead and fill in the first angle for both of the firsts, and you fill in the second angle for both of the seconds. All right, happy mathing.